Today we'll study about fold. Here comes to the median length. The line that joins the inflection points in a series of fold. That is called the median length. Median line, sorry. Line joining inflection points in a train of fold. If it is a 3D thing, you can say involving a median surface. So, median surface is going to be cross section region, median line is going to be. So, two line through which we can bound a fold. Fold extend को हमें bound करें. This is one line, and this is another line. So these two lines, you can say enveloping surface or enveloping line. Like you can see here, this is the surface, but we call enveloping surface. Here one, another top up, you can add another surface like this. If you take a cross section, it will look like a line. So these two surfaces, they bound the fold, they are called as enveloping surface. They are called as enveloping surface. Or in case of cross section, they are called as enveloping lines. They limit the fold, you can see. So the distance between two enveloping surface is called as the height of fold. This is the height of fold, that is the distance between the two enveloping surface. But enveloping line is the distance called the height of the fold. Then from the median surface or median line to the enveloping surface, either to this or to this. This is called as the amplitude of the fold. Amplitude, it is the distance between median surface, distance between median surface or median line and enveloping line. Upon the amplitude, and this can be your amplitude, and the distance between two consecutive inflection point is called as your median length. By the median length, median so median length is the distance between two consecutive inflection point. Consecutive inflection point. This is M, this is A. From these two parameters, we can define the aspect ratio of the fold. Aspect ratio, which will be amplitude by median length. Amplitude by median length. So this The distance between two crests or two draw, you can say that is your wavelength, and the median length can be considered as your width of the fold. Median length of तुम कहीं परियो otherwise width of the fold. Understood? Interlimb angle. It is the angle between tangents drawn at the inflection point. So the inflection point रे the tangent data draw करिया. So जितनी angle इतनी measure करिवे. That is होची interlimb angle. It is the angle between tangents drawn at the inflection point. We can also determine another thing, that is a fold angle. So the fold angle, if you draw perpendiculars to the inflection point to perpendicular draw करिबो from the axial plane. Axial plane में एटी perpendicular draw करिबो. So that will produce a angle that is called a fold angle. It is phi. So phi plus I is equal to 180 will moment. This is your I, this is your phi. This is given 180. Then comes to bluntness ratio. So bluntness ratio, it is indicate the tightness of the fold. Tightness of the fold determined by. तुम्हें दीटा सर्कल में आबो गोटे तुम एटी जो इन्फ्लेक्शन पॉइंट पर परपेंडिकुलर ड्रॉ करछुंती ताकू रेडियस नहीं गोटे सर्कल में आबो एंड द रेडियस ऑफ कर्वेचर एट द hinge line. तुम hinge point पाखरे केते रेडियस ऑफ कर्वेचर अछि. So the ratio of the radius of curvature, or the ratio of radius the circle that drawn at the hinge point and at the perpendiculars in the inflection points, the ratio will be called as bluntness ratio. Okay, RH by I. RH होउछि तुम्हारा radius of curvature at the hinge point. RI is tomorrow radius of curvature radius of circle, you can say, drawn at inflection point. That is used tomorrow bluntness ratio. That is your bluntness ratio. Next we'll move to classification of fold. So fold can be classified on the following basis. One is geometric classification, and also genetic classification. First we'll study geometric classification. On the basis of geometry, fold are divided in number of ways. That is on the basis of closing and facing direction. First is synform, antiform, and neutral. So the type of fold as well. Synform, antiform, and neutral. So synform, it closes downward. It closes downward. Antiform, it closes upward. Neutral, it closes lateral or sideways. It is. Can also draw like this. This can be also neutral. So synform, we can say opens upward. It opens downward, opposite, and it opens sideways or lateral. So in synform, you can also define on the basis of convex and concave term. So it is concave upward, convex downward. So this part you can say convex, this part is concave, this is your concave, this is your convex. So upward concave, this is upward convex, upward close, upward convex, downward open, downward concave, then upward concave, upward open, downward convex, downward close. Synform, antiform. So in synform, all the pair will dip towards the center or towards each other. You can see they will dip towards each other. But in antiform, they will dip away from each other. So in synform, they will dip towards each other. In antiform, they will dip away from each other. This is the characteristic of antiform synform. Okay, on the basis of stratigraphic relationship, on the basis of the two types, you can say syncline and decline. So in syncline fold, you will find younger here and older at the periphery. So in the core, you will get younger rock, periphery older rock. In anticline, you will get older rock at the periphery, younger rock at the older rock at the core, younger rock at the periphery. And the same shape will be like synform and this is like antiform, but mostly it is defined on the basis of stratigraphic relationship. You will find any shape if you'll find younger rock at the core, it will be syncline. If you find older rock at the core, it will be anticline. So accordingly, to the synformal shape pouch, but you are finding older rock at the core, younger rock at the periphery. It will be anticline, but the shape is synform, so that's the name is given as synformal anticline. And we find younger rock at the core, older rock at the periphery. That will indicate a synform, sorry, for syncline, and the shape is here is an antiform. So the name will be antiformal syncline. So this symbol, this symbol indicates the younging direction. That means that this is the younging direction. In that direction, you will get younger bed. So एक सिंपल माने बुझिपाରୁଛ कि जो डायरेक्शन रे दिया है सेटा यंगर बेड रे इंडिकेट करछ एटा ठीक भूल अछि ताको यंगिंग डायरेक्शन को ठीक देखो ता माने एटा बाहर दिया है माने बाहर तुमे यंगर रख पाइ एटा जो डायरेक्शन देनी से अनुसार तुमे यंगर कंडीशन पाइ. So these type of for a synformal anticline, antiformal syncline, those will indicate overturned condition. जो कि बेड रा overturned है. Like this bed, देखो एमती overturned है ये. पर तुम्हारे anticline पहले थोड़ा सी ये उसे देखो antiformal syncline. One two bed करियो. So it two है जो चोकुर approach, one approach, one third approach. So order of superposition अनुसार सबरे जोटा ऊपर रहेगा सेटा younger, तला रहेगा older, unless until कि there is a deformation. So it is a deformation condition. The older ta upper polochi, younger ta thala. Same condition the antiformal syncline or synformal anticline. Then comes to fold on the basis of interlimb angles. So fold can be classified into these types on the basis of interlimb angle. This is the isoclinal fold. So that's why you can say the interlimb angle is 0, or sometimes you can consider less than 5. Isoclinal fold, you can say fold has 0 interlimb angle. That means ki the inflection line if you draw, if you draw the tangent at the inflection line, it will be parallel to each other. The tight fold has 30 to 0 degree, then closed fold 70 to 30 degree, then open fold 120 to 70 degree, then gentle 180 to 120 degree. So as you know, tomorrow interlimb angle plus fold angle, this will be 180 degree. So these can be also represented on the basis of fold angle. So sometimes for a fold angle will be greater than 180 in case of fan fold. So this will be your fold angle. So fold angle when greater than 180. So if tomorrow 5 will be greater than 180, then I will be negative. Negative interlimb angle. So negative interlimb angle is produced when fold angle is greater than 180. So it is in certain overturn fold में fan fold रे पाई परियो negative interlimb angle है तो fan fold condition है तो मैं negative interlimb angle पाई परियो. So all these interlimb angle they can be represented on the basis of fold angle. Then gentle portion the 180 to 120. So in terms of fold angle, it will be 0 to 60 degree. 0 to 60 degree. So similarly, you can also define open, close, and tight and isochronal. This comes to symmetrical fold, asymmetrical fold. Symmetrical fold, so it will have an axial plane which will divide the fold into two equal halves, or axial plane will be a mirror plane. In case of similar fold, axial plane is a mirror plane, and it should be perpendicular. Axial plane is perpendicular to mirror plane. Then each for a limb, they should have equal dipping angle, whether they are dipping away from each other or towards each other. Deep at equal angle. So these are the characteristic of a symmetrical plane. Perpendicular to axial plane, it will be a mirror plane, and we will dip at equal amount. We will have equal amount of dip. Then it will be considered as symmetrical fold, and it look like an M-type fold. So M type of fold will be. So all these characteristics will be absent in asymmetrical fold, where the axial plane is not a mirror plane, where axial plane is inclined, with axial plane is inclined, and the limb will dip at unequal amount, or dip karibe, and this can be called as a Z type, Z or S type, Z or S type of